Hi y'all. This is the video review for your Unit 4 test. I have not been cleared by the doctor yet to go back. I will be back on Thursday if my chest x-ray turns out to be okay. So just kind of a rundown of this week. Today I'm going to be going through the review with you. If you don't want to watch the entire video in one sitting, that's okay. You can pause it and come back to it tomorrow. But my goal for you to have done by Wednesday is to have this test review finished. Any other work that I've given you while I was out for the week after Thanksgiving break, that needs to be completed as well. So pretty much you have Monday through Wednesday to finish up any work that you don't have done from this unit, as well as study for your test. So your test is going to be on Thursday. It is going to be open note. So if you have the review finished, your test should be super easy. I'm only doing that because I think it's a little bit unfair for y'all to not have me there and then be expected to be tested over it and do well. So that's why I'm making it open note. So if you have the review and it's finished, you basically get a good grade on the test if you know what's going on. Okay. So I am going to first start out by finding roots by factoring. So for number one, all of the times when you factor, you start off with that I. A times C goes at the top and B goes on the bottom. This is my A, B, and C. So on the top, 2 times 3 is 6, B is 7. So I need two numbers that multiply to 6 and add or subtract to 7. Those two numbers are 6 and 1. After that, you can either do box method or double distribution. I'm going to do double distribution because I like that better. You're going to take these two numbers and you're going to replace that plus 7x with those two. So you're going to have plus 6x plus 1x plus 3. Then you're going to separate this into two groups and take out the greatest common factor on both sides. So between 2x squared and 6x, the largest thing you can take from both is 2x. 2x squared divided by 2x is x, and 6x divided by 2x is 3. On the other side, they don't really share anything larger than 1, so I'm just going to put plus 1. And then what's left over is x plus 3. So I know I did this correctly because I have x plus 3 as my matching term. So my factored form is 2x plus 1 times x plus 3. And since I'm solving it by factoring, I'm going to take each one of those and set them equal to 0 to help me solve. So I'm going to take 2x plus 1, set that equal to 0, and then x plus 3, set that equal to 0. Here you're going to get negative 1/2 as your answer. And then here you're going to get negative 3 as your answer. So you get two different solutions with number one. Okay. Number two, you are using the rational root theorem to list the possible roots. So the rational root theorem is that x equals plus or minus p over q. Your last number here, this is p. And then the first number that you see here, this is q. So these numbers are actually quite simple. Plus minus 5, plus minus 5. The factors are what you're listing on the top and the bottom. So the only factors of 5 are 1 and 5. So if you make your little table, I'm going to have plus minus 1, plus minus 5. Same thing over here. Remember that these represent the top of the fraction and these represent the bottom. So over here, 1 divided by 1 is 1. 5 over 1 is 5. 1 over 5. And then over here, for the last box, if you do 5 divided by 5, you get 1. But I already have plus or minus 1 as one of my factors, so I'm just going to leave that one blank. So the possible roots that you have are positive and negative 1, positive and negative 5, positive and negative 1 over 5. So that's all I need is that table written out for number 2. For number 3, you're going to use synthetic division to test if some of these possible roots are actual roots. And I'm telling you which numbers I want you to test. So if I'm testing -1/5, this one's going to be ugly because it's a fraction. I know that we're not super strong with fractions, but if you get stuck, you can always use your calculator. So I'm going to put -1/5 out here. And then the original polynomial that I was looking at is this. Okay, and then you're going to use those coefficients and set up your synthetic division. So I've got 5, 29, 19, and -5. I don't need any placeholders because my exponents go from 3 to 1, 0. Okay, so in my synthetic division, always bring down your first number, and then you're going to multiply 5 times 1/5. So I'll do that over here. Sorry, it's -1/5. So these are going to cancel, and you're going to be left with -1. That number goes here, and then you're going to add going down. So 29 plus -1, or 29 minus 1 is 28. Then I'm going to multiply 28 times -1/5 gives me -28/5. You're going to put that number here. Add going down. Here's where you can use your calculator if you want to. I need to do 19 minus 28/5. So in order to combine those two, I need a common denominator. 19 is the same thing as 95/5. And then I can keep that denominator of a 5 and do 95 minus 28 on the top, which gives me 67. So I'm going to have 67/5. And then I'm going to multiply 67/5 times -1/5, which gives me -67/25. Goes here. So at this point, if you want to type this in the calculator, that's fine, but I'm going to tell you right now that the remainder there is not going to be 0. You get -192/25 as your remainder. So if something is a root, that means that when you do synthetic division, the remainder is 0. In this case, the remainder is not equal to 0, which means that my root of, or my possible root of -1/5 is not a root. So if your remainder is not 0, that means that whatever number you were testing here is not a root of the polynomial. Okay. For part B, I'm going to do the same thing. I'm going to put -5 out here. My coefficients are going to be the same as what they were for the division above. So you're going to take these numbers, and then they're going to go in that same spot over here. Okay, this one won't be as bad because we don't have as many gross fractions with this one. Okay, so -5 times 5 gives me -25. Add going down gives us a +4. +4 times -5 gets me a -20. Add going down, -1. -1 times -5 is +5. Add going down, and look at that, we get 0 as our remainder. So since the remainder is equal to 0, we can say that x equals -5 is a root of our original f of x. The last one that I'm testing is -1. So you're still going to use the same setup that you did from the last problem. So I'm going to keep the 5, 29, 19, -5. Bring down your 5. 5 times -1 is -5. Add those two together, we get 24. 24 times -1 is -24. Add those two together, you get -5. -5 times -1 is +5. add those two together, and you get 0. So again, since the remainder is equal to 0, that means that x equals -1 is a root of our f of x. Okay, moving on to the factored form portion. So this f of x that you see here is the same one that we've been working with throughout the rest of the video. The two things that I know are that x equals -1 and x equals -5 are roots. We already discovered that through synthetic division. So that means that x plus 1 and x plus 5 are factors. Okay, so whenever you have the root version versus looking at the factored version, those signs are always going to flip. So since you have a -1 as your root form, when you look at it in factored form, you're going to see a +1 instead of a -1. So I know that my two factors are x plus 1 and x plus 5. I'm going to take my answer from 3c. So looking back at 3c, my original f of x, I'll just rewrite it here. Okay, this was my original f of x. It had the highest degree of 3. Synthetic division brings you down 1 degree. So if my highest degree was 3, my new highest degree is going to be 2. So this 5 is now the coefficient of x squared. This 24 is now the coefficient of x. My -5 is now my constant. So my f of x right now, I have the two factors of x plus 1 and x plus 5. And then what I'm left with from my synthetic division up here is 5x squared plus 24x minus 5. Okay, this is not in completely factored form yet because I still have that blue term that's there that I need to break off into a factored form. So I'm going to factor the 5x squared plus 24x minus 5. So at the top, I'm going to have a times c, which is 5 times -5, gives me -25. On the bottom, I'm going to have 24. So two numbers that multiply to give me -25 and add or subtract to give me 24 are 25 and -1. I'm going to do my double distribution, and I'm going to turn this into that middle term. Break it into two pieces and take out the GCF on both sides. So over here, I can take out a 5x from both, and I'm left with x plus 5. On the other side, I can take a -1 from both, and I'm left with x plus 5. So this, factoring it, remember that your matching term is one of the factors, and then the other factor comes from the combination of the two GCFs. So you have 5x minus 1, and then you have x plus 5. But x plus 5, that green factor, I already have it included in my original factored form, okay? So I already kind of know that this is one of the factors, so I'm not really going to pay attention to that. I am going to pay attention to that 5x minus 1. So my entirely factored form is going to be x plus 1, the x plus 5, and then the 5x minus 1. And if you want to double check that that is correct, you can always graph that factored form that we just found and then graph the original form. So what I'm circling here in yellow, you can graph those two. If they're the same graph, then you've done it correctly. If they're not the same graph, then you know that you've done something wrong. You need to go back and look at any mistakes that you could have made. So graph the two and just make sure that they match. Okay, for number 5, we're going to use the factored form of question 4 to write out those roots as points. So Our factored form is this. And I want to use this to find the roots. So I'm going to set each one of these factors equal to 0. And then I'm going to solve each one of those for x, and those are my solution points. So x equals -1 means that -1, 0 is a root. X equals -5 means that -5, 0 is a root. And then x equals 1/5 means that 1/5, 0 is a root. So I have 3 different roots that are there. Okay. Number 6, it wants us to identify the end behavior and draw the graph. So I'm going to rewrite our original function here. Okay. Identifying the end behavior means that you're looking at the degree and you're looking at the leading coefficient. My degree here is 3, and 3 is an odd number. That means that my graph is going to be pointing in 2 different directions. My A value is 5, which is a positive number, which means that the right end of my graph should be facing, which means that the right end of my graph should be facing up. So right end of my graph is facing up, and I'm going in different directions, which means that my left end should be facing down. So I'm just going to do super quick sketch of this. I'm going to plot my zeros. So I have -5, I have -1, and then I have 1/5. I know that my graph ends going up to the right and down to the left, and then I'm just going to draw my graph through those points. Okay, that's probably not what your calculator looks like. It might be a little bit steeper on your calculator. That's just kind of a rough sketch of what's going on. That's all I really need for you to draw. If you want to graph it in the calculator and do a super accurate graph for me, that's fine too. Okay, the next portion, this is the kind of like the increasing and decreasing notes that we did. First thing I would do is type that into your calculator and graph it. You do not have to type in the -5 and the 3. I don't think that your calculator can register that. So I'm just gonna, I graphed this on Desmos. I'm just gonna draw like a really rough picture of what it should look like. But if you want to use your graphing calculator, you can do that. Okay, so that's just a super ugly sketch of your graph. Again, if you want a more accurate picture, you can do Desmos or whatever you want. So I'm just concerned about you figuring out what the different key features are here. The interval that you're looking at is this -5 to 3. So on your calculator, any x values that are smaller than -5 or bigger than 3, we're just going to kind of disregard those, and I just want to look at this section of the graph that's between those 2 x values. Okay, so your x-intercept's written as a point. On your calculator, you can graph the equation, and then once you've graphed it and you're sitting on the graph page, you can do menu, trace, graph trace, and you can move the arrows side to side until it says the word 0. When it says the word 0, those are your x-intercepts. So those points are here. Whoops. Okay, so I've got 3 x-intercepts. You can continue using that trace function to find the y-intercept, or if you look at your equation, the very last number that you see, that is also your y-intercept. So my y-intercept here is going to be at 0, -3. Okay, your domain is what I have in that like red cloud up there. That is your domain, but it wants you to write it in interval notation. So remember that whenever you've got a inequality symbol that has no line under it, that's a parenthesis. And then if you do have a line under it, that signifies a bracket. So my domain, if I'm writing it in interval notation, I'm going to go from -5 with a parenthesis to +3 with a bracket. And that's basically just looking at your x values. So this is your smallest x value, that should have a negative there. And then this is your biggest x value. So I'm looking at those 2 points. Okay, your range is from the bottom of the graph to the top of the graph. So I'm paying attention to the y value that's here and the y value that's here. Now, on your calculator, if you graph this and you don't type in that restriction that's there, which you shouldn't, I don't know if you're able to on your calculator or not, after you graph it, if you go to Control-T and then you scroll until you find that x value of -5, it should give you the y value that goes with it of -28. It's just that given the restrictions of the -5 and the 3, we're never actually going to touch that x value of -5, and we're never actually going to touch that y value of -28. So when I'm writing my range, the bottom of the graph, which is still at this point down here, the y value that's there is -28. But since I'm not going to touch that point, I'm going to use a parenthesis. So I'm going to go -28, comma. Then I'm going to look for my largest y value, which is all the way up here at 132. And that is a closed circle. This is like a closed point right here. So I do actually touch that point, so I'm going to use a bracket. So -28, 132, and then close that one off with a bracket. I think on my answer key on Google Classroom, I have a parenthesis, but it should be a bracket since you're actually touching that point. Okay, increasing intervals. So I'm looking for places where my graph is going upwards. Remember that the increasing and decreasing intervals, you're only paying attention to the x values when you're writing that. And then you always use parentheses. You never use brackets. So looking at my graph, I don't know what color to use. From that x value of -5 all the way to this point is at -3, 24. All the way between here and here, you are increasing. Then my graph goes downwards, and that happens from that x value of -3 to an x value of 0. I'm decreasing. Then I go back up again one more time, and I'm increasing from the x value of 0 to the x value of 3. So I'm going to try to write that out for you. So my increasing intervals, I start at -5, and then I increase until I hit the x value of -3. And then I turn to decreasing. So now I'm going to go to letter G on my decreasing interval. I'm going to decrease from the x value of -3 until the x value of 0. That point, 0, -3, the y-intercept point, you're not going to take the -3 value because you only want the x value, not the y value. So I decrease from -3 to 0, then I change direction again, and I'm increasing from 0 to 3. Since there was a break in my increasing interval, I'm going to use that U, that union symbol, to show that I had a break in my graph. Okay, this next part is pretty straightforward. You're either given a graph and you have to write the factored and expanded, or you're given like the roots and you have to write the factored and expanded. So for this graph, I'm going to look at my x-intercepts first to help me write my factored form. Notice that your scaling is 2, not 1. So if I'm halfway in between 0 and 2, that point would be 1, 0. This is 0, 0. And this is negative 1, 0. In your factored form, you're going to flip your signs. So my factored form is going to be x plus 1 instead of the negative 1, x minus 0, and then x minus 1. So when you simplify this, the x minus 0, you don't need the minus 0, nobody cares about it. So that x term that's here, you're just going to bring it to the front. And then you can have your x plus 1 and your x minus 1. You can really write the x, like if you wanted to write it as like x plus 1 times x minus 1, that's okay. It's just weird looking. We usually don't write it like that. You'll always see it with the single letter in the front. So that would be your factored form. For your expanded form, pick 2 things that you want to focus on. So I'm going to pick the x plus 1 and the x minus 1, and I'm going to multiply those 2 things together. So x times x gets me x squared, and so on. You can get rid of those 2 terms in the middle box, and you're left with x squared minus 1. So now the 2 things that I have highlighted are the same. I am missing that little x that's in the front. So I need to, for my final expanded, I need to multiply that x, I'll do it in blue, with this x squared minus 1. So you're going to distribute that x to both of your terms. X times x squared is x cubed. X times negative 1 is negative x. So that would be your final expanded form. So try to kind of color code everything here. The x squared minus 1 came from me multiplying x plus 1 and x minus 1. Once I got that result, then I distributed the x that was in the front to those, and it got me the x cubed minus x. So that would be my factored and expanded form for those. Okay, the very last question, the critical pieces of information here are that we have a double root at 2, 0 and a single root at 4, 0. So a double root, you should be thinking squared. Okay, so when I write my factored form, I'm going to have x plus 2. Remember to flip your sign. It's going to be squared since it's a double root, and then a single root at 4, 0. So then I'm going to have x minus 4. So this is my factored form. For my expanded form, I need to multiply everything out. So x plus 2 squared, let's focus on that first. That means that I'm multiplying 2 copies of x plus 2 together. Okay, you can combine the 2 middle terms. So you're going to get x squared plus 4x plus 4. So what I have now is this portion and this portion are the same. I still need to multiply in that x minus 4. So now I'm going to take what I have from the blue highlighted, and I'm going to multiply it in with the green highlighted. So you have x squared plus 4x plus 4. Then my green highlighted is x minus 4. And you're going to multiply all that out. Okay, combine whatever you can. So these two are going to cancel with each other, and then you can combine these two here. So we're going to have x to the third minus 12x, negative 16 plus 4 is negative 12, minus 16. And that would be my final expanded answer. Okay, so that is your review. You are working on any other work that you need to get finished from this unit. You're working on the review. Your test is going to be open note. So if you have this review finished, you are good to go for your test. I will see you on Thursday when I get back.